Hey everyone, it's STEM time with Navya and Aishwarya. We are your hosts, Navya.
And Aishwarya. So, following the theme of last week, for today's episode, we will be doing an extension to Dazzling data structures. This is a bonus episode because we are officially ending our first season. We have pretty much covered as much as we can about the basics of computer science, and next season we hope to cover more advanced topics. And we can't wait to teach you guys more about complex topics um, and so don't forget to keep listening and waiting for our upcoming episodes next season. So now let's get back to our topic for our final episode for the season, Dazzling Data Structures Part 2. Before we dive in, Navya is going to give you guys a quick update on the current event for today's episode.
So, the current event for today is that on June 2nd, a research team at the Yale and US College found that haptic feedback, such as vibration feedback, causes distraction, but this loss of focus lasts only for about 1 second. So, the findings can help designers improve the usability of notification features in our devices.
Cool. So let's go over our agenda. The questions we will be addressing today are: what is the benefit of using data structures?
What are the two kinds of data types?
What are the basic operations used for the data in data structures?
And how can data structures use recursive functions?
So let's dive right in.
So our first question is, what is the benefit of using data structures? So data structures is a way of storing data in the disk space of the computer or memory storage in a way that the data can easily be used and manipulated in the future. And it is a very effective way of performing various operations related to data management.
So our second question is: what are the two kinds of data types? So data type is a way to classify various types of data, such as an integer, string, etc., which determines the value that can be used with the corresponding type of data, and the types of operations that can be performed on the corresponding types of data. So the two data types are built-in data type and derived data type.
So built-in data type are data types that are built in the language. So for example, most of the languages provide the following built-in data types: integers, Boolean, which is true or false, floating, which are decimal numbers, and characters and strings. And derived data type are data types where the implementation independent as they can be are independent as they can be implemented in one or another way, which are these data types. These data types are normally built by a combination of primary or built-in data types and associated operations on them. So for example, these operations are list data types are list, array, stack, and queue.
Great. These can also be known as primitive, composite, and abstract. And let's define these a little bit. So primitive is like the basic building block. So a Boolean, integer, float, or char. Composite is basically any data type composed of primitive and or composite types. And examples of these are like a struct, an array, or a string. And our last one is abstract, which is a data type that is defined by its behavior. And examples of abstract include tuples, set, stack, queue, and graph.
So, what are the basic operations used for the data in data structures? So, basic operations include traversing, which is printing all the array elements one by one, searching, which is essentially searching an element using the given index or by the value. Insertion is adding an element at the given index. Deletion is deleting an element at the given index. Sorting is arranging data or information into an ordered sequence, and merging is taking two or more groups of data and combining them into one single unit. So for this information, we would like to thank tutorialspoint.com for providing us with detailed information about data structures.
So let's move on to our next question. How can data structures use recursion? So there are many examples of recursion, and it's a really useful technique for both the definition of mathematical functions and for the definition of data structures itself. So if a data structure can be defined recursively, it means that it can also be processed by a recursive function.
So there are many mathematical functions that can be defined recursively, and these functions include factorial, Fibonacci, Euclid's GCD or greatest common denominator, and Fourier transform.
Just like how many mathematical functions can be defined recursively, there are many problems that can also be solved recursively, like games of all types, ranging from simple problems to more complex ones, for example, like chess. So in games, the recursive solutions are particularly convenient because having solved the problem by a series of recursive calls, you want to find out how you got to the solution. But by keeping track of the move chosen at any point, the program call stack does what you need it to be done.
So one of the simplest examples of a recursive definition is that for the factorial function. So the factorial of n is equal to, if the n is equal to 0, then 1. Then else it would be n times factorial of n minus 1. So that's how you would define the factorial function in programming. A natural way to calculate factorials is to write a recursive function which matches this definition, which is the function definition being if n is equal to 0, return 1. Else, return n times factorial n minus 1. Thus, this calls back the function right back to the original function, meaning that it is a recursive function.
So what Navya mentioned, note how this function calls itself to evaluate the next term. Eventually, it'll reach the termination condition and exit. However, before it reaches the termination condition, it will have pushed n stack frames onto the program's runtime stack.
So this termination condition is obviously extremely important when dealing with recursive functions. If it is omitted, then the function will continue to call itself until the program runs out of stack space, which is of course really, really bad and won't turn out well. So make sure you always have a termination condition.
So before we sign off, let's talk about the termination condition because it is very important. So basically, the termination condition is a condition which terminates a series of recursive cells, and it also prevents the program from running out of space for stack frames.
So for example, with this factorial function, the termination condition would be if n is equal to 0, then return 1, which will ultimately prevent the function from going into the negatives, which is not applicable for factorial functions. So for this information, we would like to thank the website cs.auckland.ac.nz, which provides a lot of lessons about data structures and computer science in general. So it's very helpful if you want to go more in depth into these topics. So please check out that website. So that's it for today about dazzling data structures. Part 2 episode. I hope you guys had a fun time listening to this podcast episode, and don't forget to tune in to our upcoming podcast. Feel free to reach out through our Instagram page, STEM Time Podcast. Please follow our Facebook, Twitter, Instagram, and YouTube accounts. Don't forget to keep learning new things. See you in the next episode. Bye-bye.
Bye, guys.